Welcome to this webinar. The topic that we're going to be discussing today is taming, coupling, and cohesive beasts with modularity patterns and Spring. So let's get on with it. So you all are developers in one way or the other. You understand that creating an enterprise system is hard. There's different phases, different life cycle, from starting from vision to requirements to design to architecture to coding to testing to implementation. We all know that. But what I'm going to be focusing today is not on creating an enterprise system, but maintaining the enterprise system, enhancing the software, not just enterprise, any software, enhancing it, adding new features, and then keeping it relevant. That is even more harder than creating the system. Now, there is a reason behind that, because if you look at the life cycle of a software product, 30% is approximately the time that you needed to create the software. But the rest of the cost and time is spent in making it relevant, enhancing it, adding features to it, changing the features as the business changes. So that's where the life cycle and the cost is spent most. So considering that, you would expect it to be difficult, but is this change necessary? Change is necessary, and change is essential, and it's not only necessary, but it is desirable, because if you're not keeping your software relevant, the software will get dated, the system will be hard to use, and it will not be, it will die a slow death. And to give you an example of where the growth is and how it is relevant, this is the source code from Spring Framework itself. At the time when the Spring Framework came in March 2004, that's the data that I have, the lines of code was about 14,000. 14K was the lines of code. But if you take a snapshot today, in August 2013, the total lines of code is a whopping 1.3 million. Now, this is not an accident. This is this has been 7 years, but this is essential. This is required, and because of this change, because of this growth, is why Spring is still being heavily used. And so it's not something you have to say, okay, software cannot grow. It needs to grow, and it has to grow to have it relevant. But then, why is it difficult to enhance or retain an application? Why is it so hard? To give you a little bit of background story or where my interest is and how this whole topic came about is we released a project, a large enterprise project, couple of years back, and in the span of last 2 years, we made about 35 releases, both minor and major. Now, when you make these incremental changes, these additions, things change, right? And you break certain things, then you fix them. You break certain things, then you fix them again, or you make new additions, new enhancements, and things like that. That essentially, the initial design that you had, the picture perfect design, the reviews and things like that you initially had, that picture tries to change. And once you go back to the code and look at it now, you will see that it's a completely different entity than what you started a couple of years back. Now, so what happens is now if you go into the code base and then you put a new developer in there, it will be difficult for him to understand what it is and how it grew, because he has only snapshot of what it is now. So the difficulty arises from the fact that a developer spends too much time in understanding existing implementation. And at the time when you created the system, the class names would have made sense. The class names were created in respective architecture layers, starting from presentation to business to persistence to whatever, would have made sense. But because the class names were generic, the responsibility kept changing responsibility, things getting added, and so the responsibility becomes too wide and too complex. And business rules tend to spread as well. You want to make a small change in one of the modules, and then the change is critical, essential, that it needs to be done immediately. So you go to the place where you can make the easiest change and not necessarily the ideal place. For example, if the change is in business layer, but it is easier to make the change in presentation layer, and you don't have time, you make the change in presentation layer. So now what you're doing now is you are introducing a deviancy in your design. So that's how the business rules getting spread across the architecture. And again, not necessarily change in the business rule, I'm interjecting in different layers, but even within a layer, you start to put too many ifs and else and things like that, and make it more complex within the existing implementation. And this is a very typical Java use. Let's say you have one module dependent on another module, and the main module says, okay, I'm going to use that interface and then start writing my code. But at some point, you needed certain facilities in the underlying implementation class, and even though you know that you have to use the interface, but the implementation is in one of the protected methods in the implementation class, you can cast the interface to that implementation class and then make use of the protected method. It's not advised, everybody understands that, but in the given time, that was the best possible alternative. So all these things raise to a term that we start using in the industry called technical debt. What it is it was a word coined by Watt Cunningham, and what he says is it's similar to a financial debt, which means you have a problem and you can do the right thing, but it is going to take a long time. But to do a quick and dirty fix, you're saying, okay, I'm going to do this quick and dirty fix. What you are essentially saying is that I am borrowing time from future. At some point, I will fix it, not today. At that some point is your future, and that's a debt. And you incur these debts again and again, and that's when you start making the maintaining the application more and more complicated. The other term that we try to use is design rot. Now, design rot is basically, it's a straightforward way, right? Your design starts rot internally. Your service layers are fine, your external entities and external implementation fine, people wouldn't see it. Your people who you are dealing with, the external services or dependent systems, those systems are fine, but your system, the internals of your system starts to get muddy. Starts rot, and you will see that in 4 different ways, and they are rigidity, fragility, immobility, and viscosity. Rigidity is that it becomes difficult to make a change. Fragility is that when you make a change, the system breaks down in all kinds of places. You don't know why it broke down, and then when you go back in and say, oh, I made a small change in a completely different place, but there is no one knew that it had this kind of a dependency in a completely unrelated place, and that's where we broke it. Immobility is that you created a module, you thought you will be able to reuse this module in place else, but the more you make changes to that module, it becomes less and less reusable. So that's your immobility. Viscosity is your changes seeps through. You make some changes to some layer, you never expected it to make it to the lower layer or impact the lower level layers, but somehow they seep through. Those are your things, and then we end up in a place called Big Ball of Mud, a shanty town. I've given links at the end of the presentation. You can look at all of these. These are heavily discussed in both research and in the market. So you end up in a big ball of mud. And you must be wondering, well, I don't have that problem. My code is good. If you do think, I would say go back to your projects and then look at classes that have util in them, that have helper in them, and that have manager in them. And then look at the classes and then see, are they doing what you initially thought they were supposed to do? Chances are these helper classes that were small technical helpers now started carrying business rules. The utilities that were simple, reusable classes starts getting business functionality, some constant physics that are applicable only to your business module, and then they are becoming less and less reusable. Manager, they were supposed to be a simple funnel to your underlying, facade to your underlying implementation, will start to have a lot more ifs and else, and that's essentially leads to this suffering at the business level. But let's see how does the suffering for the developers. Now, you force your team members to continuously work long hours because they spend a lot of time in understanding the code, and even when they fix it, it goes and then breaks so many other things, and then they go back and then try to find out why they fixed it. So you force your team to work long hours. The second thing is you heavily depend on your best team members because only they understand these complex beasts that you created. That essentially makes that either your developers are not able to understand the complexity or handle this kind of a complexity, and they try to move out. If not, you send them away because you don't know. You think they don't know how to work with the system. It creates psychological divide between development, testing, and the DevOps team. The teams do not start. The trust between the team goes off, and the testing team says, unless you give me a code, I cannot do the testing. And even when they do the testing, they add multiple cycles just to make sure that the changes that you make, even though you call small, may have cascading effect. So that's how the psychological divide comes in. You are essentially setting up your team members to play safe. So you know that this is the best way to make this change in the business wants. But if you do it, you don't know how it's going to affect in other areas, or you think that it will have a cascading negative effect in so many different places because of the way the code was hacked later on. You just play safe and say, okay, this is the best thing, but I can only do this for the given time frame, and then the business starts to see that as a bottleneck in their change. Basically, all of this leads to an unpleasant work environment, and at some point, we put the blame on technology and say, this is really old, this is really ugly architecture, I'm going to start over the project completely new in a new platform, new technology, and that's how the cycle goes. But once you know that you have reached this pain point, you have unleashed the beast. And what we're going to discuss today is how do we tame the beast? It's there. You create a project, it runs through half of life cycle, and then it becomes a completely different beast. So how do you tame the beast? For a minute, let's go back and see what would be the ideal situation. If a project is created initially, how would you change the situation? What would be the end result that you would expect from this exercise? The first thing that I would say is confidence, right? The confidence in embracing changes. The business changes all the time, but when the change comes into the implementation team, you say, bring it on. I know what this is. I can guarantee that this change, if I make it to this place, will give you what you expect, but this is not going to affect anything else. That's how the design is. That's the confidence that you would want in your team. Pivot. Pivot is, your initial constraint, your initial assumptions when the project started was something else, but business evolves, and at a later point, though all of those constraints are gone, now you need to pivot your design to accommodate to the new realities. So how do you pivot your design without having cascading disruption into other areas of the code? So that's your ability to pivot at any given point of time without cascading effects of that. The third thing is at the base level, comprehension, understanding of the code, not just the code, but what the code is trying to do, basic business and business constraints. If I look at a code and then I walk through my implementation, can I understand what the business is doing with all of the business rules and constraints that are applicable at that point? Or do I have to fish through the code in 10 different layers and then get an understanding of it? Because no matter how much good your documentation and your process flows and things like that, code is ultimate living document. So if you cannot understand code, your maintenance becomes a nightmare. Now there is a law behind this, and then you can Google it. I have added the link at the end of it, and that's called Lehman's law, and there are 7 of them. What I'm particularly want to highlight is the second law, which states, as a system evolves, its complexity increases unless work is done to maintain or reduce it. So when system evolves, its complexity increases. That's the nature of the things. But you cannot contain that complexity unless you specifically take time to either reduce it or maintain it. That is how you can address this. So what kind of work you need to do? What do you do? How do you retain the maintainability? The answer is refactoring the design. Now we all know refactoring. The tools, Eclipse-based tool, including STS, gives you the incredible ability to refactor, pull out the methods, change the method names, and all of that. Those are essential class level refactoring. But what I wanted to highlight on, is refactoring the design itself, right? Specifically, physical and structural design. So when we talk about design, you can come back and then say, I have a good architecture. I have a multi-layer based architecture. There is a presentation layer, there is a business layer, there is a persistence layer, and then all of that is good. And I deploy it in an application server or a web server, and then I instruct my team to say, whenever there is a new screen or a new function, you need to follow this architecture layer, and they create the classes. So I do the design. My design is good. That's good. The other argument that I often hear is design patterns, the GOF design patterns. You say, not only that, I go into my individual classes and I have my design patterns, and I have my single pattern, factory pattern, bridge pattern, adapter pattern, and all of that is being applied to the right place. So what kind of design are you talking about now? Now, I want to talk one level above that. I want to talk about patterns called modularity patterns. Now, what modularity is goes at the heart of physical structure. So your design patterns, your other areas would have given you classes, methods, packages, and then you would have bundled them in a var. But how do you design modules and modules? If I wanted to, I'll come back to this. The way it is designed in this book, Java Application Architecture by Modularity Patterns, with examples using OSGI. The definition of a module is the ability to reuse, the ability to compose. So if that is the case, the definition of modularity is a jar file. So it's a physical file that you can touch. It's a physical file that you can attach it to something else. It's a physical file that you can deploy it, undeploy it. It's a physical file that you can specify that this is what it is doing. So that is the module that we are talking about. Now, a package in a different way, yes, it is a module, but can I physically deploy it separately? Can I physically touch that as separate and then say, if I make a change to this module, no other classes are going to be changed? It's not, yes, it is possible, but you need to put a lot of controls to retain that modularity. So the essential boundary that we try to set ourselves on a module is a jar file. So that is what I wanted to highlight here, is that you not only have to design your classes and methods that is at the lower level and the higher level architectural layers, but you have to design the middle layer, and that is your modular jar modules as well. And the solid design principle helps you in designing the classes and packages. Your framework helps you designing the different layers, but your domain model, your domain-driven design written by Eric Evans is a good reference for domain modeling. Your domain model helps you create the physical structure of it, and the different patterns in those physical structure is what is discussed in this book. Now I can give you a snapshot of all the patterns. We have base patterns, dependency patterns, usability patterns, extensibility patterns, utility patterns. But the idea for me today is not to go through all of these patterns one at a time. I think his book does a good job. I will probably want to go back to this book and give you a book name. It's called Java Application Architecture, Modularity Patterns with Example Using OGA. Now, don't worry about the OGA part for now. The book has very little of things to do about OGA, but have to do everything with modularity patterns. So if you are getting worried or often concerned about OSGI, just don't worry about it. It has very little thing about OSGI. So the goal today is to give you an example of how different patterns influence the implementation. And for implementation, you not only need the right design, but the right tool set. And what we will pick for here is my choice of the tool is Spring Tool Suite, and then app server like a Tomcat, and then not only that, you will have to have the tools, the frameworks for the underlying implementation, and then we're going to choose Hibernate, Spring Boot, which is the new framework that came in, and Groovy. Spring Boot, you should probably check it out. There is going to be a seminar couple of weeks. I hope Peter will explain that. But you need not only the right design, you need the right tools to address this problem, this cohesiveness problem. So let's go down the next one. One of the patterns talks about cohesive modules, and the one-line explanation for this is module behavior should serve a singular purpose, right? It should serve a singular purpose. That's what cohesive module is. You'll ask, that's what I've been doing. I mean, my modules are cohesive. What do you mean by it's not cohesive? But the pattern takes it to the next level. It says a module is cohesive when all or most of its components are changing at the same rate. So the rate of change is an important indicator to see whether you have a much larger module or a very fine-grained module. The next one it says is the frequency of reuse or the classes that are necessarily needed together for them to reuse a specific feature, that also decides the boundary of a module. Right? Let's say, a simple example is, let's say we're looking at a billing module. Billing is a module, and you can say I have a WAR file or a jar file that handles all of my billing. And if you go into the details, you can say here is a package for doing the invoicing. Here is the package for doing customer details and then products and then tax and service. Or you may even look at saying my customer module is separate, I have a dependency on that. My taxation is separate, I have a dependency on that. My product module is separate, I have dependency on that. So you can still consider product and customers and things as separate modules and then have billing depend on that. But if you go into the customer, they themselves can be categorized into different sub-modules because your customer demographic information is not changing at the same rate as the discount rates and or the type of customer they are in, a small, medium, enterprise, and all of that. The information changes differently at different times. So by combining them together as one module, one entity, you are making it much more susceptible to change because the thing that changes fast is combined with the things that is changing slow, right? So that is not what cohesive is. If they are changing at different rates, split them separate. So we'll have to look at customer information as a separate jar and customer discounts as a separate jar. Obviously, customer info, the root that is will be the dependent for these two. Now, the same way, if you go to product side of it, your product details, product pricing, product inventory, product vendors are all independent modules because they all have separate things, but they still come under product service. Right? So when I'm re-looking at the billing module, I don't need the entire customer module or entire product module. I need the customer discounts that are applicable for certain types of customers and the pricing that I can use to generate the invoice. So you create cohesive modules that are changing at the same rate and that have the same type of reusability. That's what cohesive module means. Abstract modules. The next pattern I wanted to talk about is abstract module. What that says is depend upon the abstract elements of the modules. Right? So if I go back one slide above, the billing has to depend on product pricing. So if I'm going to depend on product pricing, let's say there is a pricing service that you have an interface in the class, and you say, okay, billing module should use only the product pricing. Good. I will use the product pricing interface, and then the product pricing module takes care of a different implementation, and it knows when to use the whatever implementation, and that's good. But what is stopping you from using one of the implementations? So you import the interface, you did the classing, you use that to get the pricing, but certain products have some special conditions, and those conditions are available as protected method in the product pricing, and you wanted to use them in the billing module. So because you don't have that in the interface, it's a protected implementation detail method, you wanted to do the right thing by pushing that into the interface, but with the time constraint, you said, I will cast my interface to the specific billing service and I'll use that abstract features. And so that is a clear violation. So how do you do that? Abstract module, you were saying depend on the abstraction. That's where the next one comes in, is that says separate abstractions. It's in the extensibility side of it, and it says place abstraction and the classes that implement them in separate modules. So if I keep my abstraction and implementation in two separate modules, and in the parent module, like a billing module, I wanted to use the pricing service, but pricing service is available only, the dependency, you retain it to only the spec, or your abstractions, then even if you want to, you cannot really cast the IMPL because the IMPL is in a completely different jar, and that jar is not dependent. You do not have dependency of that jar in your billing module. Right? That's a separate abstraction. So the way you will see that is there is a taxation spec, and there is a default implementation for that, and you can have different states. In the United States, you can have one taxation scheme for Illinois, another taxation scheme for Wisconsin. You get the idea, which eventually leads to what we have adopted heavily in our project is two separate modules, one for spec, a jar module that will only have interfaces and abstractions, and the other one is IMPL. And if I need to extend it, I will have the specific extensions from the IMPL. Coming back to solid is certain principles that Uncle Bob prescribed some time back. Solid stands for S stands for single responsibility principles. O stands for open close principles. L stands for Liskov substitution. I stands for inversion interface segregation principle. D stands for dependency inversion principles, and those are the ones that will help you create classes with specific scope and then create packages with a very limited scope. So if you implement the spec and IMPL, the interfaces and the classes will honor these design principle as well, like the single responsibility principle, dependency inversion principles, and solid, part of solid principle. The next framework that I wanted to talk about is implementation factory. Right? Use factory to create modules implementation classes. So I was talking about this guy, right? So there is a taxation spec, and there is a default implementation, and there is Illinois extension and Wisconsin extension. So if someone wants to use the taxation spec, and they wanted to use Illinois because they are in Illinois and they wanted to use the Illinois taxation service. How do they get up to Illinois? And you can say in Spring I can probably use qualifier and put one qualifier for the default and another qualifier for the Illinois. And in the place where I'm going to use, I will define the interface for taxation spec, and I will use the qualifier for the Illinois. The problem there is because we said I'm going to do the abstraction, your billing module only knows about taxation spec. It has no knowledge of Illinois taxation spec. So how do you get it? And that is what is addressed with factories. So you will have to create factories to provide specific services for a given state. Now, I'll show you how this is done in Spring in the demo section. Demo time. But eventually, you can use. That's where the facilities that the tool provides can be used to answer the design. So it's not you use the application framework and you use the tools and then do the design. It is other way. You do the design first, both domain model and architecture and your class diagrams, and then you find out how you can visualize this design using the tools. So I'm going to show you how it is done with Spring. So you will start seeing taxation service, tax service factory, and then abstract factories, and then IMPL, which will have the default service. The next thing that I wanted to talk about is manage relationships. It's another pattern, and the simplest definition is design module relationship. Obviously, you have two relationships. What the emphasis is design. What this means is that let's say we have billing module and there is invoice, there is customer, there is product information, there is taxation, and that's how the billing module entire runs. There could be other modules, but just for our argument purpose. When you have it, you clearly have to design that this particular module depends on these other modules. And in Spring, most of the projects use either Maven or some form of dependency management, and which means that you will have to go to Maven POM and then specify that this particular jar can only have these other jars for a given runtime scope. Now, with that, you will be able to manage your relationships and not leave it up to developers. You say, okay, this is available in this class, and this class is available in this package, in this jar. I want to put that in the POM. So instead of leaving it to the developers to dictate what modules are dependent on what other modules, you design the dependency. And if someone is violating that, you will know right away because the modules will start mixing up, and then you will see the mix-up in either using a tool called Jar Analyzer, or you can go to the POM and then see is it having the modules that I wanted, right? So the next thing that you need to be very sure is not to have acyclic relationship in the module, right? There is module 1, which has class A, and it depends on module 2, which has class B. That's fine. But in the module 2, there is a class C is now depending on class D from module 1. So you see, the classes are not cyclic dependent, but the modules now become cyclic dependent. So that is the one that you need to try to avoid at all costs. And there are ways to do that, and the simplest way is you inverse the dependency. Right? If you inverse the dependency, you can break a cyclic relationship. And design, when we talk about taming this modularity, is not just applying solid principles or modularity patterns. You need to look at the domain-driven design as well. You need to have the domain model properly created, or you need to refactor the domain model so that you can guard against changes from other layers. And one of the layers that we typically work with is external system. and there are multiple ways you can handle external system dependencies, and one such way is called anti-corruption layer. Now, what this is, you have your use adapter modules and create corresponding spec and IMPL for that fulfillment, right? So if I go there to the invoice service, there is an invoice service spec which is a separate jar module, the invoice service default IMPL, and then invoice service client extension. Right? Certain features are overwritten. Now, once you have it, one of the scope is to automatically dispatch the invoice as a PDF to the ERP system or a proper XML to the ERP system. If that's the case, dispatching is a requirement. So you write your code in invoice service depending on the dispatch. Now, the dispatch will have an IMPL which will have default, and then that IMPL will work with an external ERP system through the adapter created for that product. So you create adapters for the external products and then shield them from the changes to your internal application. So now let's go to demo time. The demo class has not all of the source code, but I wanted to show you how you can extend it. And this is in my local. I'll upload it to the GitHub. And if you guys can find my email address and on Twitter handle, you can send me a note on one of them, and I'll share the source code. It's also going to be available in the video that Peter will talk about it later. But the thing that I wanted to highlight is, let's say you have a service called for a given state, for a given place in the state, what is the tax rate? It's a very simple service. Now, you'll have to ignore the method parameters and return types. You could have done big decimal and then given the proper state enum and proper 6+3, 6+4 zip codes for US and all of that. But this is an illustration to help us understand how this can be done. So if you look at the taxation service, this is the tax spec, and there will be IMPL. Now this one is here. So there is an implementation, but if you see the implementation, it doesn't do anything here. It says find the tax rate for a given zip code. That means there can be different tax rates for different states, and those tax rates changes completely differently. So you cannot simply create a factory class and have all the state tax rates, different tax rates in one of the jars. You will have to keep them separately so that each of the state can change independently without affecting the parent class. So how do you do that? So what we do here is we first find a state tax rate service, and now this class is a very simple service. It says find the tax rates for a given state zip code, because it knows the state, and then you need to create a default one. So this is the default one. It says if I don't know what it is, I'm going to return a specific rate, and then you go in and there is a qualifier for this, and this is available in State Tax API IMPL. Right, so that is the State Tax Service IMPL. Now, the other class that I wanted to highlight is you can extend this and then say for Illinois state the rate is different, or you can probably at this point I would say you would be having an adapter that goes to Illinois tax service or some other facility that gives you the change, and then that adapter have to be injected here, because the external service that gives you all the taxation facilities can be different from different client, and there are 100 different products, so you need to create adapters, and adapters can be injected here. Now that's well and good, but if I go here, right, so I have a factory, and with that factory I give a state and then say for this particular state give me factory. So how does this factory comes in? How do I get the factories of implementation? That's where we use something called abstract factory. So if I go to this Spring XML, and I use the Spring locator, service locator factory bean that tells me that you can give me any abstract factory with a map, and that map needs to have a key value pair. And if somebody is giving me a particular key, I will go to this map and find out the bean that implements that key that is mapped for that key, and I'll return you the implementation. So Spring owns the entire part of implementing the service locator factory bean. So all we need to define is an abstract factory and specify a bean, and in that bean you can say if it is default or if it is nothing specified, you give me default state tags, and which is what you will see here. But if a different state is there, that state may have other factory and it will have other service. So how do I extend that? So if I go to the state rate service, this is what we said, that we overwrote or overwritten the state tag service with Illinois, but you can say that it has the factory. Now in this factory, Illinois state tax factory, what I do is I inject that bean, the bean that we saw here. It's a properties factory bean. I inject the bean here, and I have a little post construct that says when this particular bean is loaded onto the memory, you do this work, register Illinois. So I'll say go to this bean and get the bean object and put that for a key for Illinois, return this factory, the factory that I have visibility to be in. I have visibility in the Illinois site, so return myself. So what essentially means is that your Spring loads the basic XML for default, and when this jar is added as a dependency and this bean, because it has add service annotation, it will try to load this bean into the memory. When it does, it goes to this one also has access. It goes to the post construct, and in that post construct, add the current factory and the service bean to the abstract factory. So if I go back to my service IMPL and then say abstract factory, which is this, get me the service factory for the state Illinois, it is going to not return me the default service factory, which is here, but it's going to return me the Illinois service factory, this guy. And from that service factory, if I say get tax service, I'm going to get this tax rate service, which will have a completely different. So the place where I will use, for example, I'll go to testing this. So if I go here and I say abstract factory, give me Illinois, this service.find rate is not changing. So I don't make a change to my base class. So there is no change in the base jar. Sorry for that. There is no change in the base jar. This is non-intrusive injection of dependency. That's how I extend my base and then create customizations that I can then do whatever I want to with that customization. So I don't change this XML. I don't change this IMPL. All I'm saying is for this particular factory, there is an additional external factory, and that factory is available when somebody is passing this particular state, right? So that's how you do it. So I can run a example, and let's see. So if I go to this test and go to run configuration, I say run tax calculation in the state tax IMPL. And if you look at argument, I can say Illinois, it will give me my Illinois tax rate, which is 7.5. So if I go to here, it's 7.5. But if I go to default, which is the This guy, it's 6.5. So if I go back to the same run method, where is my run configuration? If I go back to the same run method and I pass in, select the same class, but if I pass in the default as that, it'll give me 6.5. So when I pass in default, this factory comes in, this IMPL comes in. If I pass in Illinois, the abstract factory returns me this factory class, and from that I get this service, and that's the value how it is done. So this is how, by creating modular service, and then by using the facilities that tools provide, like Spring provides, you can create an extensible, manageable implementation, and that is how you basically extend the seams of the system, and you not only architect at the top level layering, not only design the simple classes under the layer, but you architect all the way down. And that is how you tame this modularity. Now, this is easy to say, but it's not that easy to find out the boundaries of the modules, create cohesive modules at the beginning. Now, if you can, my recommendation would be to actually start with the modular design, but a lot of times it's not possible. But you start with something simplistic, and it evolves over a period of time. When it does, when you encounter either a design debt, that means you try to create some shortcuts, some quick fixes, some quick wins. If you do that, I would say record those hacks, debts, and wins, and then make them publicly available. It gets tricky when you have an onshore offshore model, but trust me, it makes much more easier for you to handle those situations in the future. But so whenever you deviate from your primary architecture, primary code base, which you will have to do at some point, you record those. And once you have them in recording, every 6 months or so, review those inventories. And when you think that you are paying too much interest on that, or your design starts rot, and then you start to see this inflexibility, this rigidity in your system, you plan ahead of time for a separate release for paying the principal. And once you have the inventory, and once you have the plan, and then you know the time estimate, you need to go back to your stakeholders and get their buy-in. And once you have the buy-in from your stakeholders at the appropriate time, make sure that you refactor the design, not just classes. You create cohesive modules. You manage the relationships. You eliminate acyclic relationships between modules. Because once you create cohesive modules and the classes were once were non-cyclic, the classes were cyclic, but because the module was acyclic, now you split them into different modules, you will start getting acyclic, remove the cyclic dependency. You then use the right tools to provide extensibility, provide understanding, and then bring out the seams of the system. So, for example, your services may be coarse-grained, but within the coarse-grained service, you may have smaller fine-grains, and you only want to change that smaller fine-grained service for a particular implementation, for a particular client. You bring down the seam and then provide similar extension for that small service alone, small method alone. You don't have to recreate the entire interface. The coarse grain interface, the coarse grain interface can remain as is. In fact, there is a pattern called published interface. Now, what that published interface is you publish your core service interface separately, and that is the only thing that external dependent system should use. And internally, you can have your own small sub-interfaces that exposes the seams of the system, and you can have extensibility on those sub-interfaces, but those sub-interfaces are not exposed. You refactor your code. Now, at times, you may need to deploy, undeploy at runtime. So what I have been talking so far is at the design level refactoring. But refactoring the modularity at the design level. But when you need modularity, you not only need the modularity at the physical level, you need the modularity at runtime as well. Runtime modularity is what OSGI actually brings in, and it's just different things. But my emphasis is not on OSGI as such. You may have the ability to stomach OSGI in your project at this point or not, but that's not the focus. What I wanted to highlight is that whether you adopt a runtime model like OSGI, and if you wait for a couple of years, hopefully you will get Jigsaw, which is another modularity that we are trying to, Oracle is trying to add into the core Java itself. Through its a regular JCP process. So the project is called Jigsaw. No matter what you choose, you can take use of runtime facility, and that gives you a lot of flexibility. But you don't have to wait for a runtime modularity. You can use the facilities, the technologies that is available today, and create your code in a cohesive manner that can benefit from that runtime environment later on. So that is the gist of what I want to talk about. Thank you so much for listening to me until this time. My Twitter handle is its_Param, and my email address is param.rengaiah at aspiresys.com. It's my first name dot last name at the company that I work for called aspiresys.com. If you want to continue the conversations, I suggest you either reach out to me in these two. You can also go to my blog where I have a similar posting, a non-technical posting around the same subject. We can continue the conversation there as well. It's a Medium blog. The blog is in Medium, and it's medium.com/its_Param. So I'll show you that. So that's what I wanted to conclude, Peter.
Sure. Yeah, no problem. Thanks, Param. There's a couple questions for you in the panel here. Some of them are more comments, actually, and less questions. But I thought this was kind of amusing. Torin comments that, this is kind of funny since the Spring Framework started as a way of eliminating having a factory for everything.
Yeah.
I thought that was kind of amusing. I responded to him and said, yes, that's certainly true, but doesn't mean factories don't have any place in system design. But would you say something about that?
Yeah, I think that's a good point. There is certain perception that once you take a technology, the technology kind of either reduces, or some people even go to the extent to say eliminate the design. See, your design is for the domain model, and technology comes in to help you fulfill that, and it aids you into a certain extent to make sure that whatever design that you come up with is implemented in the right way that suits your context. That doesn't mean all of the designs are removed. For example, the factory is a good one. Even within Spring, you will have many such places where Spring itself has a lot of factories, which means that it's not eliminating factory within itself. The same thing applies for the business concern as well. So at certain places, when you need factories to create certain domain entities, you would have to create those factories. Technologies or frameworks are not a drop-in replacement for domain. Domain are for the content. The design is for the domain. Design is for the context. Technology is to realize those those domain models. So I would try to keep them side by side, not one for the other.
Related question from Mitesh Kumar. He said, for the factory example, couldn't we use enums or properties?
You can, but the service locator factory bean expects a bean. So it gets a little difficult if you use a simple enums and try to serve a bean, then you will have to write a lot more, or you will have to your factory will have to know all of your extensions as well. That's the problem that we get in. So with service locator factory, you don't have to make these extensions aware on the parent abstract, either the abstract factory or the base level doesn't have to know all the detailed extensions. The extensions themselves come in like a visitor pattern and then add themselves up. Whereas if you have a enum or any other way, wherever you declare, you need to have either class.forName or you need to use the Spring Bean injection, and then you somehow have to make them aware of those extensions in the base class.
Excellent. Okay. Let's see. A couple of other, I think there was just one or two others. Let's see. Bear with me for a moment. Torin McCabe also comments. He says, it looks just like the observer pattern, many possible things listening. At runtime, you order them and add to get the behavior you want.
That is very right. It is an observer pattern. It's the observer pattern in a true sense is if somebody is making some other change, you let me know because I have to make changes myself. That's more of an observer or observable. What we are doing here is it's basically a staging that when you create the base, look out for these other dependence objects as well and have them register to the base so that the listener or registration scope ends there, whereas the usage is it doesn't know when it was added. All the usage is I am this particular person, I need to get this function, I'm going to ask my abstract factory, he's going to give it to me. So that's the distinction between typical observable pattern whereas this service locator pattern.
Got it. Okay. Hey, we got a bunch of other questions coming in. Just a comment from Joe Panko saying, hey, good presentation. Class diagrams would have been helpful to visualize the concepts. So maybe just a thought for you as Param is going to be presenting at Spring 1 on September 9th through 12th at Santa Clara Convention Center. So maybe a piece of feedback for you there for your presentation.
Definitely. I said I wanted to retain it at the package level, at the module level, but the examples are kind of rough. I'll give the class diagram, say which module has which classes, how they are related. That's a good feedback. Thank you.
Danny Grolin asks, what are some overall strategies to offer modularity in a system, yet handle multi-tenancy from many different kinds of customers with different customer needs?
It's an excellent question. In fact, modularity, the whole reason why I had to recreate my project to satisfy modularity is for multi-tenancy. So what happens in multi-tenancy, or at least the way I had to need it, is not multiple installation with the same code base. It's a common code, and there is extensions, customizations for different clients. So single installation, single code base with a common base package, but certain clients need certain additional features or deviations. So that is where we wanted to make sure that we create a spec for the services, each of this. But before creating spec, we had to go through this cohesive module pattern, make sure that we have as much as fine grade as many modules as possible, create a spec for that, create a baseline implementation that is common across all the modules with standard defaults, and whatever clients that you have, you provide an extension for those clients, and not only implement the entire service for each client, but only the areas where they change. And that's where the themes becomes very, very important. If you have, let's say, a customer discount, you are applying customer discounts, and then the entire logic to find the type of customer is same, but only for certain customers, when their amount is increasing certain different things, you make this additional something like that. You have some additional business rules that is very focused on such very small area. You only push that to a small interface in the sub-services, and that sub-service is what you need to override for the customer. So your themes are visible, and then you compose. The other thing that I want to highlight is composability. Right, so you take your individual jar files, and then even if you want to create separate deployable var modules for different clients, you take your common jar modules, you add your additional extension jar modules, compose an independent var module, deploy that in your server, and you have an extensible, manageable, composable architecture. And that is the promise of modularity.
Yep. Could you go back to the slide that had the web link on it, Param? Just while we're answering a couple other questions, because someone was asking for your blog web link.
Right. So that's good. I'll come back to that. So this is my blog. It's medium.com / my Twitter handle at its_Param. And the topic that I put, the relevant topic there, is regaining your development team's confidence. You can go in and then start, we can continue the conversation there.
Excellent. We've got a couple more questions, so I'd love to move off this if you don't mind.
Sure.
Pooja Gupta asks, can you repeat in brief what you said about placing a place abstraction and the classes that implement them in separate modules? For a while, I thought you were advocating not to separate them.
If I understand your question, the example that I gave, there is a service and there is a factory, and it seems like I've placed both the service and the factory at the same place, and then I have a default implementation where the service is implemented and the factory as well, and the abstract factory is also in the service. That's one way to do it. You can extend it further and take the abstract factory and the factory onto its own module and keep only the service. That is possible. The only drawback that I see is that, again, the pros is that your service, the syntax of the service changes very rarely, but your factory is hardly changed. So if I apply that constraint, yes, it makes sense to push out the factory and abstract factory into its own jar and keep only the service, and have my parent module depend on both the abstract factory and then factory jar and the service jar, kind of use that. That's a good thing. What I didn't want to confuse here is create too many fine grains. So at some point you will feel that your granularity becomes too much. So at some point you have to balance it out, and at least for the example, I wanted to just put it both the factory and abstract factory and the service interface in the same place, and then give an implementation at the IMPL. Having said that, it's again because of my bias. At some point I started with 8 jars, and then we ended up with 98 jars in my projects. With this, having service and factory and abstract factory as one. So if I would have extracted them as separate, looking at a higher number. So that probably was the bias of doing that. But if your scope is less and you wanted to really apply the comprehension pattern, yes, it is right to keep the interfaces and the factory and the abstract factory separate in 2 separate modules. It makes sense.
Excellent, thanks. Let's see. Danny Grillian asks a follow-up question to his earlier question about modularity and multi-tenant systems.
Right.
And his follow-up question is, offer multi-tenancy with modules, yet try to avoid breaking existing functionality for already implemented customers. It seems like more of a comment than a question. Danny, it appears you're still on the webinar, so if you want to maybe clarify that a little bit, or sharpen that up into a question in the Q&A panel, that'd be great. Pete asks a question: how do you modularize business rules that are housed in a rules engine that have just run out of control? They're not housed in proper services. The only solution is to redo the rules to be encapsulated in services, ? Or can we refactor the rules within the engine somehow?
It depends on the rules engine itself. Now, if you used a rules engine like Drools or something, it becomes difficult because then you end up with the limitations of the rules engine. I can give you what we did. we tried to look through a lot of different rules engine for our systems, and we ended up against the wall. So what we did is we went through a route called DSL, Domain Specific Language, and we picked up Groovy. So the Groovy and using Groovy as a domain-specific language and creating the facts and then measures and then did the rules that way. So when you have the DSL-based language, your code is not that bloated. Groovy language is a beautiful language, and if you create enough closures, you can pretty much make it look like English. And create rules that very much looks like your rules that you would define on a rules. But with the full control that I have with Groovy language and DSL, we were able to segregate parts of rules. So you when you look at a big rule engine, you have to break it down into silos. You have to break it down into a functional area, saying these rules are applicable to this, these rules are applicable to this, rules are applicable to rules, this silos, and externalize services for those silos, and those services is what then becomes your individual module. And Spring has beautiful support for Groovy, and then you can inject those into the same extensibility pattern which we did, and then use appropriate services to go into the individual rules, and then you can run those rules within the scope of that module. So that's how we solve that problem. But yes, if you use the tool and the tool gives you a black box and you try to modularize the rules within that, then you are within the boundaries of the tool. I don't think I can help much on that.
Got it. Yeah, that makes sense. I think we're almost at the end here. Just one or two more questions. Balaji asks, instead of a post construct an annotation on the factory class, could it have been better to register to a service locator?
It is. We tried both options. The post construct was easier means to self-register. The other, I have not tried it. If Balaji can shoot me an email what his thoughts of, I can reply to him in a more technical sense. But we tried few different things. This post construct was simple, efficient enough solution for us.
Got it. Okay. Let's see. Indrajit, if you asked a question about requirement for creating baseline, if you're still on the webinar, if you'd like to sharpen that question up a little bit, we're not quite sure what you're asking there. If you could clarify a little bit, that'd be great. Just go ahead and do that in the chat window, and we'll take care of that. Let's see. Sanjeev asks, so how different, and we kind of talked about this already a little bit, but Sanjeev asks, so how different is this approach than from that of using an OSGI model?
OSGI is a good question. OSGI, if you look at the book itself has an OSGI at the end of the subtitle. OSGI gives you both structural and runtime facility. Now, there are the industry, a lot of people are advocating OSGI, but OSGI for enterprise application as such was adopted very recently, maybe a year back or 2 years back is when they released it. It was focused on product. In fact, Eclipse uses very much on OSGI, and that's probably why OSGI survived it. My point here is that whether you choose to use a runtime model or not, if you have a complex system and you want to manage the complex system, you don't have to wait until you find a runtime supported environment, because that's an additional tool. My focus is focus on the design. You should be able to refactor the source code and then use the existing tools and then make them cohesive now. And when you do need the runtime support, you can look at an entity like OSGI or even the project Jigsaw. Or I'm sure Spring is trying to look for its own solution. But you can look at all those runtime models when the right time comes in. You don't have to wait till that time to refactor your code.
Yep. Actually, we were the initial sponsors of the Eclipse Virgo project. It was originally something called DM Server from Spring. So we've had a solution there for some time. But Yeah, I think we've been kind of seeing some of the same trend that you mentioned, Param, in terms of just, OSGI being somewhat niche. Certainly there's some people that are interested in it, but, it just, never really, and at least from what we're seeing, it never really got the adoption that we thought it might.
And that's why I don't advertise it as such. And I say don't use that as an excuse. You have other design things and you have other technologies that are available today that will help you go to that direction.
Exactly. Okay. Unfortunately, let's see. I don't think Inderjeet heard me, and he hasn't had a moment to clarify here. So Pramod is just asking, and a couple of people are asking for links referred to in the talk. So maybe if you could just flash up a couple of those links again.
The slide share is going to be up in the slide is going to be up in the slide share, and whatever links I have given, it's all in the references, so you can go to any of those links.
So this is probably the right time for me to say that we'll be posting this as a replay on our YouTube channel within we say 2 weeks, but usually I get it done within a week. And that YouTube channel is on. I'll put the URL here again in the Q&A panel, but it's youtube.com/SpringSourceDev. And we've been sending out a lot of email demand generation lately for our conference, so we're not going to be able to do a follow-up email like we usually do to the folks that attended the webinar, letting you know when the replay is ready. So I would encourage you, if you want to get notified, that you go to the YouTube channel and you subscribe for the time being, because then when we post the replay, you'll get notified about it immediately. And let me just finish typing the URL for you guys here. There we are. I did spell that right. Okay. Yes. So, and also in the comments of that YouTube video, in the description of that YouTube video, we'll make sure to have links to Param's slides on SlideShare. But, I think Param has done a really good job of making a speaker deck so that, a lot of the meat of it is in what he said. So I encourage you to watch the replay and share it with your colleagues. Param, if you feel moved to, there is one more question asking to talk more about multi-tenancy, but there's nothing very, very specific about it. So if you feel like you have something more you want to say, feel free. If not, we can conclude the webinar for the time being.
Yeah, I think that's fine. Multi-tenancy is a much bigger topic, so I don't think we will have time. You can reach out to me on my email and with the specific questions, and we can take it offline.
Excellent. All right. Well, listen, thanks, everyone. Really appreciate your time and your attention. I would like to draw your attention to, if you haven't registered for Spring 1, that's coming up very quickly, and is going to be located in Santa Clara, California this year at the Santa Clara Convention Center and at the adjacent, I believe it's the Hyatt Hotel. So Param's going to be speaking there and delivering a version of this presentation. Also, if you are folks, the next webinar on September 5th, we're going to be talking about Pivotal Tracker. Our good friends from Pivotal Labs are going to do an overview of getting agile with using the Pivotal Tracker tool. And then very cool, one of the coolest new things in Spring Boot. There's going to be a webinar on September 26th after Spring 1. And if you're not able to make Spring 1, I highly recommend that you check out that webinar. That one is a real game changer. It's pretty cool stuff. And as always, we are recording our Spring 1 content in HD digital, direct from the laptop. So you'll be seeing Spring 1 sessions starting to trickle out on our YouTube channel same as we did last year. Sometime in the early October time frame. Early November, depending on how long it takes to crunch thousands of MP4s. So really appreciate your time, everyone. Param, anything you want to say before we wrap up?
Yeah, one final thing. Design is my passion, and not just the software design. I do work mostly on the UX as well. So based on my experience in the last couple of years, I've proposed a talk in the South by Southwest. If you have a few minutes, you can go through this URL. It's going to be there in the slide share, and I would really appreciate if you guys go and then read this, and then if you like it, vote for it. Just a quick thing, if you tweet about this and then I see the tweet with my handle on it, I have a couple of books to give away, so I'll pick out one or two of you guys and then give you the same book that I talked about, Modularity Patterns. So thank you so much for listening to my talk till this time.
That's pretty cool, Param. Thanks for that. And South by Southwest is a fun conference, so I hope you get picked. That would be a fun panel. You'll have a blast at South by Southwest. It's a great time. All right, everyone. We're a little bit past over time, but we like doing that when there's lots of Q&A. So appreciate your time, everyone, and hope to see you at Spring 1. Take care.